Hey guys, pardon all this, it's been a long day. Today you're going to take your SLO. This is something that we have to do, and I figured while I'm out, you might as well go ahead and do it. I'm going to be graded on two types of things. One, what your score is, and two, how much you improved from the first time you took it. So even if you don't get as high of a score as you would like, you can still have a chance to do a little bit better as long as you show some improvement from the beginning of the year. So I wanted to review a couple things today as your warm-up, and then you're going to spend the rest of the class taking this. So first I want to review what is a function. Remember, a function is where every input goes to exactly one output. In other words, the x values do not repeat. It is okay for the y values to repeat. It is not okay for the x values to repeat. So in a mapping, function would look like this one here on the left. See how all the ones on the left or the x values are going to exactly 1. Doesn't matter that this value on the right gets repeated. It's that the values on the left cannot repeat. But this mapping, there are 2 coming out of the number 2, and so that would be not a function because the x values, or the ones on the left, cannot repeat. And then if you want to tell if a graph is a function, well, if this was a list of ordered pairs, you would make sure none of the x's in the ordered pairs repeat. If it was a list of x and y values, just make sure the x's don't repeat. But if you're looking at the graph, we use something called the vertical line test. And the way the vertical line test works is there's a vertical line and you drag it from left to right across the graph, and it can never be touching the graph in more than one spot. So when I do this parabola here from left to right, it's never crossing in more than one spot. Same thing with this line, it's never touching that red line in more than one spot. Same thing here and with the semicircle. But when I bring that down to these, you can tell all of these are not functions. So if you look right here, you can see where this right here and right here is touching in 2 places. Or if I was to draw a vertical line here, you can see it's touching in 1, 2, and even 3 places on this one. So these do not pass the vertical line test. That one's touching infinitely many times. This one does not pass the vertical line test. It's touching twice. So in order to be a function on a graph, it has to pass that vertical line test. Then what if something's in function notation? So remember, this is pronounced f of x equals 3x plus 5. If I ask you to find f of negative 2, that means everywhere you see an x, you plug in negative 2. If there were 3 terms here and they all had x's in them, you would put the x in every one. Remember to put that x in parentheses in case it's negative, because if you raise a negative to an exponent, it is sometimes negative and sometimes not, according to if the exponent's even or odd. So always put it in parentheses when you're putting that negative in your calculator, and you will be allowed to use Desmos. So I'd put negative 2 everywhere I saw an x up here. So 3 times negative 2 is negative 6 plus 5 is negative 1. So f of negative 2 equals negative 1. So that means that there's a point on the graph at negative 2, comma, negative 1. That point would be on the graph. Now let's go back to some of the functions we looked before. If I gave you this function right here, the first one on the left, and I ask you the same question, what is f of negative 2 from this graph? There is no equation to plug it into, but I can go over to negative 2 on the x-axis and see where is that touching and what is the y value that goes with that, and in this case it's 4. So f of negative 2 would be 4. Whereas if I'm looking at this middle one and ask you f of negative 2, it's right there, that's at 0. If I ask you f of negative 2 on this one, it's down here in the negative section, and then f of negative 2 again is at 0. So when it says f of, whatever number's right there, that's your x value. So you look on the x-axis and you go to the graph, and what y value is the ordered pair there. Domain and range is also going to be on here. Remember, domain is all your x values, range is all your y's. I remember alphabetical order. Domain comes before range in the alphabet, and x comes before y. If I was doing this semicircle right here, the farthest left it ever goes is negative 2, and the farthest right it ever goes is positive 2. So the domain of that one would be from negative 2 is less than or equal to, and I can't put the little equal to line here, x is less than positive 2, but I'll see if I can draw it in here. But remember, it's how far left and how far right. And then if we were doing range there, it would be how far up and how far down. So the lowest this graph ever goes is 0. That's where it is on the y-axis. And the highest it goes is up to 2. So that would be 0 is less than or equal to y, which is less than or equal to 2, because that's the lowest and the highest that it ever goes. So remember, for domain, you're going left to right. For range, you're going up and down. I know this was a fast review. This is just to kind of refresh your memory and be a warm-up. I hope it helps. I miss you guys. I love you. I will see you as soon as I get all of this with my family taken care of and get myself together. Bye.